Okay, that looks really scary, right? It's all letters. It's hard to see what's going on. But I see that this is a definite integral. What's a definite integral? Numbers at the bounds, right? That's a definite integral. If you don't have, huh?
No, we're not going to have a plus c at the end. Because
oh, and that's another important thing. For definite integrals, putting a plus c will also give you a 1 point off. So you have to know that definite integrals produce a definite number, so you can't have a plus c. Indefinite integrals, when you don't have anything in here, then your answer could be anything with a plus c, so it has a free constant. That's why it's not definite. The answer is not a definite one, but it has a freedom of plus c. So for indefinite, you have to have c. For definite, you will not have c. Yes?
Kind of big trouble, but is that m plus or is that mt?
Oh, this is mt over m plus 1. Okay. All right. Another feature of the definite integral is that you do the integral just like an indefinite integral, but at the end of the day, b's should be plugged in, right? Okay. So it really doesn't matter if the integral is m or x. At the end of the day, you're going to replace it by some numbers in here, so it doesn't matter. Okay? And it's already really hard. It's really confusing. So I want to make it just slightly tad better by replacing m by x. What do you think? Would you think this is slightly easier looking? No? Yes? Like psychologically, I think it's easier.
Isn't that
it's the same thing. But if once you write it like this, you kind of see that, oh, these are the actual variables that we're integrating with, which means t is what?
okay? Constant.
It's a constant. T is just a
So you can
constant.
pull it out.
So that means I can pull that outside the integral. We pull that outside the integral. And now we have to do this integral. Okay. Yes?
So we're missing a plus 1, so we would do.
Oh, okay. So you want to do plus 1 and minus 1. That would be like one way to do it. Yeah? But I want to show you how to do u substitution with definite integrals. So let's try to do a u substitution. So I'm going to say u is this thing in the denominator, entire thing. Okay, in that case, if we apply d of u is just d of u. What happens here? Derivative of this is 1, and then you attach dx, right? So dx is the same as du. Okay. Oh, then there's this extra step. Extra step for use of definite integrals. And this extra step is, see, this is the value of x, right? When x is r, you have to know what the value of u becomes. When x is r, what is u? U is x plus 1, but because x is r, you have u as r plus 1. Now then, what about this other end? When x is 2r, what happens? U is? Yeah, x is 2r, you plug it in here, you get u as 2r plus 1. So what I'm trying to tell you is that for u substitution of definite integrals, not only things inside the integrand should change, but also the bounds must change. If you don't, you're not writing things correctly. So you have t, u is r plus 1 until 2r plus 1. I don't know what to do with x, but x plus 1 is u, and we said dx is the same as du. Okay. What should we do now?
I have to get rid of that x.
Right,
You have to change this into something with u, right? You can't have x still there. You have to complete the u substitution. So what should we do?
U minus 1.
Yeah, you solve the relationship for x so that x is u minus 1. So that now this is the integral of t, integration from r plus 1 to 2r plus 1 of u minus 1 over u du. Okay, what should we do now? What's the next step? Any ideas? How do you integrate such a thing?
Couldn't you do u over u minus 1 over u?
Right. So you can rewrite u minus 1 over u as u over u minus 1 over u.
And then would that one just be
And this one will just become 1.
It would
So it's
be
going to be 1 minus
minus
1
1
over
over
u.
u?
So did anyone hear about share the love? It's like there's one thing in the bottom and there's 2. It's like you share the denominator among both. Right? It gives you a nice heart shape. Share the love. Yeah. So you have u over u, and then 1 over u, and it's subtracted. That's what happens. Okay? And everyone knows u over u is 1. Right? Okay. So that allows us to integrate this thing by 1 minus 1 over u, and now that's a lot easier to integrate. Integrating 1 gives you u,
ln.
and this will give you ln of u, absolute value. And then these endpoints should be plugged in.
But wouldn't we still have t when we plug in?
T would still be there. Yeah, the answer should have t at the end.
Oh,
Now, do we go back to x?
no.
No, we don't. Because these are already values of u. So we did that hard work over here. So we don't have to go back to x. For definite integrals, once you have the boundaries changed, those values are u values, so those go in directly into this. So what happens is like t times 2r plus 1 minus ln of absolute value of 2r plus 1 minus t times r plus 1 minus ln of r plus 1. Should we put plus c?
No.
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 It's definite integral.
Definite integral. No plus c. Okay. All right. And then since they both have t as a factor, but let's still factor the t out. And you have 2r minus r. What's that? 2r minus r. It's just r. What's 1 minus 1? 0. Okay. And then it's this. It's minus minus, so this is actually plus. So you have minus ln of 2r plus 1 plus ln of r plus 1. And then plus c?
No.
No plus c. Okay. All right. So that's the answer. Now, this will be full credit, but let me just say one more thing. This can be, if you want, you can further rewrite this as equals to t times r, and this is plus, that's minus. You know the rule for log A minus log B? What is that?
It's like log a times b?
Nope.
Division.
It's the division. Minus becomes division inside the log, right?
Oh, minus.
Yeah, subtraction of 2 logs becomes division inside the log. So instead of having 2 logs, you can rewrite this to have just 1 log. And the top one is r plus 1. The bottom one is 2r plus 1. And it's this. So that'll be another way to write it. Yes?
Why are you subtracting it again?
This is a minus, right? So
But
it's
the-
this minus that.
Oh,
Yeah.
okay.
And since it's subtracted, 2r plus 1 belongs to the denominator.